So hello everyone, my name is Rhys Bradbury. I'm currently working for Telegraph Engineering. I'd like to start the talk by saying a special thank you to the guys at the JVM Roundabout organisers, as well as the community, for having me and listening to me blabber on about Java and Scala. And another special thank you to Sonny, who put the opportunity my way. And I just pretty much jumped at it. So I've only had about a week to get this talk together, and I've practiced it a few times, but hopefully it goes okay. I've also got a script, so I don't go off. So Java versus Scala. It's important to note that the purpose of this talk isn't to answer questions like what one's better, what one's worse, which is more robust and which is more reliable, because I think that that's to do with the people implementing it. And you know, it's less about the tools, it's more about the people. Instead, I aim to give you an insight into some of the language features that they both have. Some examples, code examples, nothing pretty at all, just some code in my IDE that I've taken a screenshot and pasted it onto the slides. I want to keep it quite light for you guys, and the intention is that it's meant to be across all levels of seniority within both languages. And I want you to walk out of the room with a means of making your own judgments about what's better. Naturally, this talk will touch on some functional programming paradigms and some object-oriented paradigms, both of them supporting some of both, especially Java in some later versions. And finally, I want to talk about some of the real-life challenges that we face. And no, I don't mean writing code. I mean the availability of the knowledge in the community, experts available, and especially around forming teams using both of these different languages. So at the Telegraph we use both Java and Scala. We've moved more towards the Java side of things now, but we still continue to develop with both. And one thing that I'm definitely not going to go on to is in trying to introduce you to concepts like category theory and those sort of high-level sort of concepts within functional programming, because we'll be here till the end of time, basically. Okay. So, as opposed to going through every single feature of the language, I decided to take some of the simpler ones and the ones that are in both. The ones that we tend to use every day, the ones that kind of go through PR, you know, we can write all of these higher kind of implementations and all that kind of stuff, but nobody can maintain them really, in my experience anyway. So we're going to go over the language keywords, we're going to go over some interfaces, polymorphism, implicits, higher order functions, function composition, polymorphic functions, generics, type bounds, and higher kind of types. So language keywords. I'm going to keep this one quick. So here we have all of the Java keywords that I just stole from the Java documentation, but they are generally the same. There are a few more in Scala, but you can write these keywords in Scala and they are reserved, so that, you know, you have to take into consideration compatibility with these things. Interfaces. So interfaces are supported in both languages. As you can see in the keyword in the Java language is interface, and there is a logical equivalence within its usage with a trait, I believe. Although that could land me in some heavy stuff with these guys over here. I'm sure they're going to take me up at the pub afterwards. Interfaces define things that need to be implemented, and you can see that in animal, it's returning void, and in Scala we have a unit or nothing for the sort of void type. Polymorphism. So, by the way, on the left is always Java and on the right is always Scala. So polymorphism is supported in both languages. Again, they somewhat look alike. And we can see here we're implementing a model which has a subtype of animal, and we can then use the animal class to then operate on that level. So it's a means of abstracting your code and reusing the same code as tested once. I'm sure you all know this anyway. So implicits, and this was in the last talk, it was slightly, we went over implicits. There's quite a lot of questions about it, and I'll be willing to answer these questions down the pub once we get down there. So in Java, there is no support for implicits, but in Scala, there is quite a lot of, we introduce implicits, and there are a number of different types of implicits. So we can have implicit classes, we can have implicit values, and we can have implicit functions. Also, we can have chained implicits, which kind of adds some quite cool stuff to Java. So on the right here, so of those implicit examples, I've only made one, as to keep it a little bit light for you guys. And this is actually a pattern that I use for my type utils library, which you can find on my GitHub. And we can see that we are creating a rich try implicitly, where we have a method called toEither, and we then do a case match to then transform those types to a resulting either type. So this is moving a try, which is a success or failure, so a failure containing a throwable, and moving that to the left, which is generally what we do with eithers if they have a throwable. Now, the important part about this is that we can, when we have a try type, so we have a try of called value A. This means that we can invoke, if we have this in scope, in implicit scope, this means that we can invoke the toEither on the try, and the Scala compiler will actually add in, at compile time, the constructor of this class around the try. So it's somewhat emitting some of the code that we have to do. So if I have an implicit scope, a means of getting from a try to an either with a toEither, if I've got a try and I'm calling toEither on it, it will construct the rich try class around it. So, higher order functions. So this is quite an interesting thing to see in Java, because I originally started programming in Java 1.6, and there wasn't much support for this type of thing. There were people trying to attempt to implement these things, and this was generally achieved by having an interface which would have generics and type bounds, where we would anonymously inline implement them as parameters, so that we could then invoke the thing that we're implementing underneath them. And that was just loads of code for, to be able to have a higher order function. But in the later versions of Java, we see this double colon. And this actually is referring to the functional interface on Java 1.8, which is referring to this function as a variable. Now in Scala, so we're passing this function as a variable, which is a higher order function, essentially. So if you've got a function that accepts a parameter, which is another function, that's a higher order function. So here we have the Scala implementation of that. So we've got a function called double salary. So by the way, this is an example which has been ripped off of the Scala language. So everything that I've got in the code examples are mainly taken from the Scala language documentation or Java documentation. We can see that we've got a function called double salary, which takes an integer and will double it, right? So that means if we map over each one of these integer values, we're going to times it by 2, double it, right? So what is the higher order function that's going on here? So map is a higher order function. So you see, if we look at the definition of map, it takes a function of a to b, in this particular case int and int, and will do its thing and execute the higher order function, the function that's passed into the higher order function to get the output result. So if we look at this here, f, which is referred to and invoked here, this is the same as our functions, our function in Scala. In Java, somewhat alike. Function composition. So here we have on the top Java. So this is Java 1.8, I believe. And we are assigning our previously shown functions for string.to uppercase, a string.trim to trim. And this is where we are combining these two functions, saying if we've got something that goes from A to B, and then another function going from B to C, then we can compose these functions to go from A to C. And this is something that I didn't previously see in Java 1.6, but it's good to see that they've accommodated it with Java 1.8. And same again in Scala, so they're pretty much quite equivalent. Moving on fast, we're going to polymorphic functions. So we see some examples previously with some polymorphic functions, and we kind of think of them like a means of generics, but specifically just for that function. So you can see for the particular a function called pop first index, the idea was that I was going to implement it, but I didn't. And we've got so we accept a list of t's being anything, and we'll return type t. So there's the equivalent in Scala. And this is something that I really like in Scala, is that we tend to remove a lot of the syntax and let the compiler do a lot of things. So generics. So a little bit like polymorphic functions. Generics are on the actual type itself. And as you can see with a list with E being the element, we can add the element, and same in Scala. Pretty similar. Okay. So I wanted to just brush over higher kinded types because they are very hard to explain. I find them very hard to explain. Let's take it that way. But the means is of a higher kinded type is to abstract over monads. So if we consider an implementation where we take a list of A's and a list of B's, and we're producing a list of tuples of A and B, and we can, so the monad in this case being list, and we also have another function where we have an option of A and option of B's, and we're producing an options of tuples of A and B, then there is some commonality between these two things. And wouldn't it be nice to be able to abstract over these things? Because if you think about it, if we can type parameterize list and option, it's the same, right? So we can do that with higher kind of types. And they can also be implemented in multiple different ways. So don't think that a higher kind of type is only just polymorph usage on polymorph functions. It can also be traits and other things as well. So those are just the quick look at the features, and these are the features that I tend to use every day. From a realistic point of view, I think that when we look at Java versus Scala, there is a lot of similarities, especially when we look at code that we actually submit MPRs and get through PRs. But generally, Scala tends to lean more towards the functional programming side of things. And if we look at it from a historic point of view, it's like Java came along, everyone started to use object-oriented programming, everyone was loving it. Then we built all these massive systems and they've got loads of this mutable state. So people started to advocate the functional programming side of things. People started to adopt these things. Scala came out and there was loads of functional programming features native to Scala. People started to use them, people started to really like them, develop their ideas and their own progress in that path. And then this sort of like this big fight around Java versus Scala came about. And then Java very much returned to, with the 1.8 releases, with the functional programming features, which kind of make them pretty much the same, I believe, personally. So this is where I'm just going to talk a little bit about the real life challenges that both of them sort of present, which is that there seems to be a lot more learning resources as well as over 20 years now worth of solved problems in Java. Although we can access and implement those in Scala, there is still, I believe, a lack of knowledge in the community around with Scala. Now, this isn't something that we can't not document, but generally, I think Java's a little bit better. But yeah, that's it.